This is 2.2. We'll be discussing basic derivative rules. We'll go over 5 of the basic derivative rules and a couple of examples. The people that were developing calculus noticed a couple of patterns that emerged, and then they kind of became general rules based on the patterns. And the first two are these ones. The first one says that if you have a derivative of any constant, it's going to equal 0. Now think of it graphically. If you were to graph some constant, let's say you were to graph y equal to 3, well, it's just going to be a horizontal line this way. And the slope of any horizontal line is equal to 0. That's why the derivative of a constant is 0. The next one is a very useful rule. It's called the power rule, which says that if you have x to any exponent, the derivative is just going to be dropping the exponent in front and then subtracting the power by 1. So if you wanted to find, let's say, the derivative of x to the 5th, it's just going to be drop the 5 in front, subtract the power by 1, and there's your derivative. If you want to find the derivative of, let's say, x squared, it's going to be drop the power in front, subtract the power by 1. And we don't usually write this little 1 in the exponent spot, so I'm just going to leave it as 2x. Alright? That's simple. Next 3 rules are going to be these ones. This one says that if you're taking a constant times a function, the answer is going to be that constant times the derivative. So that just means that you can multiply a constant times the derivative. This one just says that you can add or subtract individual terms, and you can add and subtract their individual derivatives. And this last one just says that derivative of e to the x is equal to e to the x. So it's its own derivative. So let's look at a couple of examples. Example number 1 says find the derivative to this equation. Alright, so first thing I want to do is kind of set up my notation. The derivative of y is going to be written as y prime. And I need to take the derivative of all of this. So the derivative with respect to x of x to the 4th plus 5x to the 3rd minus 6x to the 2nd. And in order to use the power rule, I have to be able to see what exponent this is. So I'm going to write the little invisible 1 and then minus 8. Okay? And I'm just going to go term by term and apply the power rule. The power rule saying drop the power in front and then subtract the power by 1. So this is going to be y prime equal to, this drops down in front, so it's going to be 4x to the 3rd. This is going to be now, the constant multiple tells me I can take whatever constant is in front and multiply it by the derivative. So I'm going to take this 5 and multiply it by the derivative of this, which is 3x squared. And then afterwards I'm going to simplify everything. Minus 6. The derivative of this is 2. Subtracting the power, it's going to be x to the 1st power plus 3 times, well, when I drop this power, it's going to be 1 x to the 0. And the derivative of this constant is going to be 0. So I don't really need to add anything. So this 8, that derivative is 0. So the derivative really just stops at this point. And now I'm going to kind of simplify this and clean this up. This is now going to be equal to 4x to the 3rd. I multiply these two, so it's going to be plus 15x to the 2nd. Multiply these two, it's going to be minus 12x. And I don't ever write the first exponent, so it's just going to be 12x. Now any power of x to the 0 is going to be 1. So I'm really multiplying this 3 by 1, so it's going to just be plus 3. And that's my answer. That's my derivative. Alright. Next problem. This one looks a little bit more complicated, but same kind of theory applies. As I want to find the derivative. Alright. So let me set up my dy dx equal to the derivative with respect to x of all of this. This is going to be 3x to the third. Again, I have to be able to see what power this is, so it's going to be minus 2 x to the first power. Square root of x, that's going to be x to the 1/2. 1 over x to the 3, this is in the denominator, so it's going to be a negative exponent. And this pi just gets recopied like that. Alright, now I'm going to go ahead and take the derivative term by term. So this is going to be, again, the constant multiple rule says I can multiply whatever constant in front times the derivative. So this is going to be 3. Derivative of this is 3x to the second minus 2. The derivative of this is 1x to the 0 power plus, dropping the 1/2 in front for the power rule, subtracting the power by 1, so it's 1/2 minus 1, so it's going to be minus 1/2. Minus, well, this constant, this coefficient that's in front, I'm going to multiply by, is like a little negative one, so it's going to be minus 1 times, power rule says drop this in front and then subtract this power by 1. And this pi is just a constant, so the derivative of any constant is going to equal 0, so this pi, that derivative is 0. Alright, so kind of cleaning this up and simplifying, it's going to be 3 times 3, which is 9, x to the second power. You're going to have x to the 0, so it's going to become 1 times negative 2 is minus 2. This is now a negative exponent, so it's going to go in the denominator. And because it's to the 1/2, it's going to be a radical, so it's going to be radical x, like that. So negative exponent goes in the denominator, it's to the 1/2, so it's a radical. And then the last piece is going to be adding these two, so multiplying, so 1 over 3, and this is going to be x to the 4th power, because it's a negative x to the 4th, it's going to go in the denominator, and that's my derivative. Alright, last example. This one up here, sorry. Find the derivative to this, so last little bit is going to be f prime of x is derivative with respect to x of all of this. This is going to be a square root of 2 is just a constant. I'm multiplying that by x to the 5th power. This 2 over x is the same thing as 2x to the negative 1st power, because it's in the denominator, so it's a negative exponent, and it's a little invisible 1 that we never write, so it's 2x to the negative 1. Cube root of x is x to the 1/3, and this is just going to be a 4 e to the x. Alright, now I'll leave it for you to try this problem, and we'll go over the answer in class tomorrow. So if you can, on your own, find the derivative to this, and we'll go over the answer in class tomorrow. And this is going to be plus 1 over x squared. Alright. One last example. This is going to be, again, I have to do the rewrite. And this is going to get me back to my derivative rules. The derivative of cosine is negative sine. Oops, hold on. Backtrack. I don't need the derivative just yet.